In this video, we're going to talk about 2.6 Objective 8, where we use continuity principles to find or graph functions. Our first question, the graph of the sawtooth function given to the right was obtained using a graphing utility in the viewing window of -2 to 2 by -0.5 to 1.5. Identify any inaccuracies appearing in the graph and then plot an accurate graph by hand. We'll actually this is multiple choice, so we'll select the correct graph where y is equal to x minus the floor of x, where the floor of x is the greatest integer function or floor function, and we should not have the vertical lines here. It should be a function. There should be no vertical lines, and it should look like A here, where the function is defined at its left endpoint and then goes up and to the right and is not defined at the top of each tooth of the saw, and then jumps back down to 0 and goes back up to make these different teeth of the saw. All right, look at the next question. Sketch the graph of the function that is not continuous at 2, but is defined at 2. So that would be A, it's not continuous. It has a point discontinuity there because there's the hole there. I'd have to pick my pencil up off the paper to draw that point, but it is defined there, so that's A. Which of the following graphs shows a function that is not continuous at 2, but does have a limit at 2? So that would be B. And the limit is where that hole is. All right, and then 3, find functions f and g such that each function is continuous at 0, but f of g is not continuous at 0. So g would have to be put into the denominator of f. So f would have to be a rational function, and we would have to, when we made that substitution, get just x left in the denominator of the composition. So that looks like B will do that for us by substituting f of g of x would look like this, and then that would be 1 over x, which would mean x could not be equal to 0 or -1. All right, because it no, it could be equal to -1. Yeah. All right. Choose the correct answer below. For f of g to be continuous at 0, f must be continuous at g of 0, but it does not need to be continuous at 0. So that's C. All right, I believe that's it. Come back next time and we'll talk about 2.6 Objective 9, where we find values of constants for which functions are continuous. See you for the next video.